Hello everyone, welcome to the video lecture series of operating system. In today's session, we are continuing with the topic Introduction to Operating System. Myself Krunal Panchal, your instructor. In this particular session, we are going to discuss the concept of system call. Means what is the significance and what it means actually, that we are going to discuss in this particular session with its categorization, or we can say classification. Fine. So let us discuss what is system call. So what is the meaning of system call and when it requires in operating system? So a system call provides an interface to the services made available by an operating system. Means what will happen in this case? Before going to understand the concept of system call, we need to understand the two terminologies, or we say two terms with respect to operating system. One is user mode and second one is kernel mode. As you know very well, kernel of operating system is responsible for memory management, input-output memory, input-output management, process management, and many more activities can be handled by the kernel of operating system. Means what? It is nothing but heart of operating system, or we can say core component of operating system. Fine. So first of all, we need to understand two terms. One is user mode and second one is kernel mode. And once you understand these two terms very well, then you will try to understand the concept of system call. So for example, suppose if you want to write a program in C, so when you are writing a program in C, at that time you are in user mode by default. Okay, but if that program, or during the execution of that program, if program requires some input output devices, like say for example, if you have written one program of calculator and for computation, okay, that program will be executed on the CPU, but when if program requires, once output is generated, that output needs to be print out with the help of printer. In that case, when you are in user mode, you cannot access the input output devices, or you can say hardware. Why? Because as we know very well, and as we have already discussed in the previous sessions, the application program cannot directly deal with the hardwares. The application program needs to contact to operating system first, and operating system on behalf of application programs, or we say user, will send a request or we say access to that hardware and provide that resources for execution. Fine. So that things you have to keep in your mind. So whenever you want to get a printout from the printer, in that case you need to switch from user mode, because while you are writing a program, at that time you are in user mode. But when you want to access any device, okay, like printer in this case, in that case you need to switch from user mode to kernel mode, so that the kernel, because at user mode, user do not have the privileges through which that person can directly access to the hardware devices. If user want to do so, in that case user needs to contact to the operating system, and operating system will give that resources for execution. Fine. So the concept is, there are two terminologies we have. One is user mode and second one is kernel mode. So when you are writing a program, at that time you are in user mode. In that case you do not require any input output devices. But when you want to get printout from something, some resources like printer, in that case you need to access the hardware devices, and user cannot deal with that stuff. So at that time, user mode needs to be context switched to the kernel mode. And once it is context switched to the kernel mode, then and then user can access that hardware devices for execution of that program. Okay, so when the user mode is context switched to the kernel mode, who will take responsibility to do such type of things? Means what? If we want to switch from user mode to kernel mode, or we can say kernel mode to user mode, that activity will be handled by the system call. So I hope you are getting. When you want to access any hardware devices like or we can say memory, in that case we need to switch from user mode to kernel mode. Okay, and this switching will be happen with the help of system calls. So there are various systems calls that we are going to discuss in upcoming slides, but these things you to keep in your mind. At that time, if such type of situation occur, in that case we need to use the system call. So there are various systems call we have. In some operating systems you can directly access the system call. In some operating system you cannot directly access the system calls. Like say for example in Windows operating system, you cannot directly access the system call. You need to you can use API, or you can say you can use library functions through which you can call the system call internally. So means suppose in the Windows operating system, if you are writing one program in C and you are using printf and scanf functions, so printf and scanf functions are nothing but library functions. Fine. So with the help of these functions, this function will internally call, because this printf requires what? Printer internally do which system call needs to be called? By having printf function write system call, because with the help of printf we need to write something on the monitor. So when you write a printf and once you execute, it means what? Internally the operating system will be called. It means what? With the help of this system call, write system call, the operating system will take the charge, or the kernel of operating system will take the charge and display the output on the monitor. Fine. So means what will happen in this case? Suppose if you write one program, okay, in C, and once you store that program, so and when you want to execute this program, so what will happen in this case? The moment the program is start executing, so we call that program as a processing operating system. Yes. Okay. So that process is reside in main memory, and operating system, or we say kernel of operating system also resides in main memory. So what will happen if that during execution of that program, if that process require, say for example any hardware device, so that process will request to the kernel of operating system first, means what? With the help of system call. With the help of system call, it will contact to the kernel of operating system, and on behalf of that process, user process, the operating system, or I guess a kernel of operating system will take charge and get the data or guess services which is required by the user. Okay, so that is the reason why system call provides an interface to the services made available by the operating system. So as I told you, two different terminology you need to understand. You can see in this particular figure there are two modes. One is user mode and second one is kernel mode. So when you are in user mode, you cannot access the hardware or you can say memory. Okay. So by default, when you are using your machine, it means what? You are in user mode. But when you want to access any hardware devices, at that time you need to switch from user mode to kernel mode, and which terminology will help to switch from user mode to kernel mode or kernel mode to user mode? The system call. So as I told you, you can see in this particular figure, kernel mode have the it is also called as privilege mode. Means what? Kernel mode or say operating system will have the privilege to access the hardware directly, but user mode, when you are in user mode, you cannot access the hardware. So means what? You do not have the privileges. Fine. So once you understand these two terminologies, then it will be very easy to understand, the concept of system call. So system call is the programmatic way in which a computer program requests a service from the kernel of the operating system. It is a programmatic way. System call is nothing but a programmatic way through which what we can do, a computer program requests a service from the kernel of the operating system. So as I told you, on behalf of user process, that request will be forwarded by the kernel of operating system, and at the end user can access the hardware. Okay. Now once you understand the concept of system call, now we are going to discuss the different types of classification of system call, or various categorization of system call. The first category is file related system call. So file related system call means what? There are various system calls are included, like open system call, read system call, write system call, close system call, create system call. So these systems call are related with the file related operations. Like if you want to open a file, if you want to read something from a file, if you want to write something in a file, if you want to close a file, if you want to create a file. So that these system calls will be internally executed, and it provide the services to the user whenever user send a request for execution. Okay. So this is file related system call. Next one is device related system calls. Means if you want to, as I told you, device means what? Hardware. Ultimately device is nothing but hardware. So hardware related or device related system calls are what? Read system call, write system call, reposition, or you can say IO device controller. Okay, these are the different system calls for a device oriented category. So if user want to read the hardware device, if user want to write something in hardware devices, if user want to change the value of a value, or change the position of a particular value, in that case reposition would be used. If user wants to control, say for example, input output controller we have in terms of this particular category, so that system call will help to control the IO devices. Fine. Then third category is information related system call, like get PID. Get PID means what? Get process ID. So what will happen? Suppose there are attributes we have in this case, get system date and time. So what it means actually in this particular category, like information system call, suppose if you have a program, so if a program, or say for example file, okay, say for example if we have one audio file, and that is nothing but because the data in the operating system may have the further informations, like various attributes, like say for example if you have an audio file, and that file may have various attributes like file name, file extension, file privileges. Fine. So a type of file. So these are the various attributes of a file. So that type of scenario can come into these particular category, information related system call. Like if you want to get system date and time, so that system call will fetch the current date and time of the particular system. Get process ID, get PPID, like process ID, or say parent process ID if you want to fetch. So in that case such type of categories system call will be used. Next one is process control, which is very important in terms of operating system. As I told you, some of the system calls, like in Linux operating system, you can directly use this system calls like fork. Fork system call is basically used to create child processes. Fine. So this in Linux operating system you can directly write the system calls, but in Windows you cannot directly write the system calls. Through APIs or through library functions we can call the system calls, and through which we can get the services that we want at the end. Okay, so process control category we have, if you want to load something, if you want to execute something, execute the process. If you want to abort the process, explicitly if you want to terminate the process, in that case these abort system call will work. Fork, as I told you, to create child processes. Wait and signal, these two are very important for process synchronization, specifically in semaphore. So to achieve process synchronization and to resolve the critical section problem, we need to use the concept of semaphore for n number of processes. So what is wait system call? So wait will do the one decrement and signal will increment the value of the semaphore. So these two system calls are used for process synchronization in semaphore. Okay, so these are the process control system calls, and the last one is communication based system calls. Like communication means what? This system call will be used for inter-process communication, IPC. Inter-process communication means what? Two independent process wants to communicate with each other. In that case, the pipe system call can be used. Create or delete connection such type of system call can be used. Shared memory system calls, SHM get system call can be used, because when you're talking about inter-process communication, the concept of shared memory can be used, the concept of message passing can be used. So for communication related system calls, these are the different system calls that we have. So these are the different categories, or we can say classification of system call. So basically system call is a small, we can say, a program code through which we can context switch from user mode to kernel mode, and ultimately we can get, or we can say we can access the hardware devices which we cannot directly access, okay, at the when we are in user mode. Okay, so I hope this was clear to you. Thanks for watching this video. See you in the next one.